so we left off halfway through chapter 3. That's the first order of business. And then after that, I'll just demonstrate some more projects, starting with the SQL injection, which I already demonstrated W600 last time, which is getting you into Web Security Academy. And then I'll do the SQL injection, which was broken last week, but it's fixed now. All right. So let me fit this on the screen. All right. So we're going to talk about how web browsers work, although some of this material is referring to technologies that are no longer used, which I'll explain. All right, so on the server side, the simplest thing, of course, is static content. You might have just HTML web pages and images that just sit there. That's the old Web 1.10, and then your web server is nothing more than really a file server. Your browser asks to see a file, and you send the file, and that's it. So that's fine, but most pages are more dynamic than that. They got dynamic content, so that it's customized for every user. When you submit the request, you do something like log in, or it has cookies in your browser where it remembers who you are from before, and now it dynamically changes the page and shows you something different. So it's running scripts on the server that take parameters from the request and figure out what to show you. And so you can send parameters in the URL query string, up here. Up here, you put parameters. You have the domain name, and then the folder, and then the file name, and then you put a question mark, and then you say query equals dog, and so on. This is the query string up in the URL. And you can put it in the path. Like here, you see a folder called 129S, but that could be a parameter. If I used RESTful style data, I can have a series of what looks like folders and subfolders, but they're really parameters. The server will interpret them that way. You can put them in cookies, which are not visible in the browser, but they're sent with every request. And you can put it in the body of requests. If you use the post method, you can just put data after the header. And so there's any other ways to do it. It can use any other part of the HTTP request. For example, people ask, how can I hide my identity from Google? Well, you could not log into anything. You could have a freshly installed operating system or clean the browser, delete all the cookies, but Google will still keep track of your IP address. And it will figure out from your IP address your general location, and it will know if you previously logged in from that IP address. And you can't hide your IP address, because not easily, because they have to deliver the data to you. Now, if you go through the Tor anonymization network, then you can, in fact, hide your IP address. So if you were to have a freshly installed operating system, never log into anything, and go through Tor, then Google would not be able to tell who you are, not until you log into anything. But how much fun are you going to have before you want to log into Twitter or Gmail or something? All right, anyway, also you can take the user agent or anything else. Any part of the request can be used, yeah.
Those other inputs, that's abstraction that the user can't see, right? That's already contained.
Yeah, most of these the user doesn't see, although they ultimately do come from the user having done things like log in. When you log in, it puts cookies on your machine, but it does it without the user seeing it. But we are used to the fact that when you go back to the page, it still remembers who you are. And if you're on a shopping site and you click a product, it doesn't forget who you are. It doesn't keep making you log in. So it's happening, but it's not obvious to the user. All right. So you're going to have a scripting language on the server, which could be any of a lot of languages. Here's some. PHP is quite common. Node.js is common. Older ones might use VBScript or Perl. You can use ASP. There's just many techniques, many programs and languages that can be used for what's on the server. The web server itself is Apache or IIS typically. And that is the program that takes the HTTP requests and serves up the pages. Now, the scripting is separate. So you'll have, for example, the most common thing you have in the open source community is a LAMP server. Linux, Apache, MySQL, and PHP. You have three utilities running on the server. You have Apache to listen for HTTP requests and serve up pages. You have MySQL, a database where you can store things like passwords and products. And you have PHP, which is the scripting language, so you can have dynamic pages that take parameters and calculate responses. In the Microsoft world, you use Windows, IIS, and ASP typically to serve the same purpose, and Microsoft SQL Server. Anyway, then you got, like I say, a database here, and then you have other back-end components, file systems, SOAP web services, directory services. There's many, many other things can be running on your server, and this is what we're going to spend most of the course doing, is exploiting these, because if you connect to a server and view a page, you are not talking to just one server. If you connect to Amazon and view the page, you're in fact sending a request to a server, which is then passed on to many other servers, and the page is built of these pieces that come from all these servers running different programs in different languages. And so it's like Frankenstein's monster. It's built out of all these little pieces, and each one of those pieces is a place where it can be exploited or hacked or make some kind of mistake. So the complexity of the web servers is really the origin of most of these vulnerabilities. So Java is what you use if you're a big company. The point of Java is hard to program in, and you can get a lot of money if you become a good Java programmer. They're in high demand, but Java is painful to program in, but the point of Java is if you write something in Java, it is very easy to expand it out to a server cluster, hundreds of machines, thousands of machines. So if you're writing an application that's going to be big, like Yahoo or Google or something, you need to use Java. PHP is more for amateurs, for like one server. My page is largely using PHP. PHP does some scripting, but it doesn't have the capacity to scale out to a large server farm like Java does. So it's all right, it runs on any operating system too. You can write Java code and it's platform independent. So there's a lot of different levels of Java, different Java products. Java Bean is a software component for business logic. Plain old Java objects are the lightweight ones. And Java Servlet are the little scripts that handle just one HTTP request. So there's many. What's that?
Is that JSP?
Yes, JSP, Java Server Pages. Yeah, I think service or JSP or something close to it. Yeah, and there's Java Web Containers, which is another thing, provides environment for this, like Tomcat. Tomcat is a web server you would get to go with Java-based websites. And there's other options too. So then you got other components that might be used, like you can have an authentication platform that takes in your name and perhaps password and other tokens and decides who you are. So you have special services just for that. You'll have special services just for presentation, special things to add to databases and for logging. And this one should be interesting. Log4j was the standard log for Java. It was used everywhere. And about 2 years ago, there was a terrible vulnerability in Log4j. They were all vulnerable. This caused everybody to have like a bad Christmas, I think about 2 years ago, because everybody in the military and in the government, I know, got orders. You must, by like next week, list every server that has Log4j on it. And this turned out to be a lot of work, of course. And this is part of how we got in the modern world, where they're increasingly making all government and military servers and many large companies, they need to have a software bill of materials. They need to have a list of all the software you're using and all the libraries you're using. So they can, next time this happens, they can just go there and see if you're using it, rather than hunt around. And that is a new thing. Most compile processes and software distribution processes do not provide a software bill of materials. You download something, like we're downloading a forensic product, Autopsy. You download the thing, you install it, that's fine. There may be a service agreement, but there's no bill of materials. It doesn't list all the products in there anywhere. It's not considered necessary to deliver software, but it probably will be pretty soon. Anyway, so ASP is Microsoft's application. This is their competitor for Java. So .NET, we'll have fun hacking it. I guess last semester we did in the 126 class. .NET is very much like Java. And now, Java, when you compile code, it is not compiled down to machine code that runs on the processor. Instead, it's compiled down to a partially compiled stuff called bytecode, which is a platform-independent language, and that runs in a Java virtual machine. So if you have a Windows machine and a Linux machine, they run different assembly code, but you can put a Java virtual machine on both of them, and then it can run the same Java code. Because a Java virtual machine is like any other virtual machine. It simulates an environment that is distinct from the hardware. And ASP and .NET does the same thing. The .NET framework, you run on the machine, and then the .NET code is in a platform-independent language that runs on it. That's called the Common Language Runtime. Anyway, so you can write the application in any language like C# or Visual Basic, and it will be compiled down to this Common Language Runtime, which is a platform-independent language called Intermediate Language, and that runs in the .NET framework, which is Microsoft's equivalent of the Java virtual machine. And again, the point of it is that it's very easy to scale out to a large cluster of servers for big companies that need to have a lot of customers receiving that service. Visual Studio is the main development environment you use if you are a Windows developer. I was surprised, even if you want to write like PHP code or something, or they want you to use Microsoft-oriented people want to use Visual Studio for everything. Even if you're writing COBOL, there's a COBOL plugin for Visual Studio. You get used to it, you live in it, just like Office people will live in like Microsoft Office and do everything in there. Visual Studio is where you do everything. And so you can write any language in there, but ASP.NET, of course, is one of the things you do. Typically, the Microsoft-oriented languages are the most natural fit to Visual Studio, but you can do anything in there. PHP is the open source language for small applications and sort of amateurs and prototyping, originally personal homepage, and then Linux, and the open source community got into these acronyms that are redundant, are recursive. So PHP hypertext processor is PHP, and the P stands for nothing. This is the new cool way to like confuse people. Anyway, this is the LAMP server you'd see if you're an open source place. You have Linux, Apache, MySQL, and PHP typically. Those are all free, and so this is what you do if you're an open source shop, or if you're a student with no money, you want to just practice and you don't want to use any proprietary stuff. And this is fine, but it tends to be insecure. PHP is particularly subject to file inclusion vulnerabilities. It is very common in PHP to have a page that will go up. Let me just put the URL in text editor so you can see it. All right. You're very commonly, if you have PHP, you'll have a page like this, https company.com/show list.php, and then you'll have a question mark, and then you'll have file equals trees dat, something like that. You'll have the name of a file here, which is going to be presented by this application, and it turns out very often that file name can be modified to be something malicious. So you can change that file, for example, to like ////etc password. This is what people often do just to prove it. If this is true, you can do directory traversal, move out of the directory that contains the pages the web developer intended to show you, and go see system files like the password file on a Linux box, which does not contain passwords anymore. The only reason you use this is because it can be read by anyone, and it's a demonstration that you have lost control. So this is called local file inclusion. Sometimes you can even do remote file inclusion, where you would make this into a whole URL. Now you can get data from another server and feed it into this script. So this is remote file inclusion, this is local file inclusion, and it's very common this happens in PHP. And WordPress uses PHP, which is one of the top products used to make web pages. You can very easily make beautiful web pages, and the fundamental WordPress engine is pretty secure. They had huge security problems, but they fixed them. But the problem with WordPress is there are all these plugins written by amateurs. You can just put in all these plugins to put like funny pictures on the page and have an address book and all this stuff. And if you aren't careful with the plugins, you often introduce terrible vulnerabilities with the plugins. Anyway, but they're based on PHP. So here's common PHP applications. A bunch of them have PHP in the name, like PHPBB. PHPMyAdmin is used to control the server. This is a common attack point for hackers. People often have insecure PHP admin pages. There's mail clients for it, photo galleries, shopping carts, wikis, many PHP-based products out there, in addition to WordPress. Ruby, I don't hear much about Ruby now. About 8 years ago, how do you remediate file inclusion? Yeah, the way you remediate, that's a good point. You remediate file inclusion by testing the file in the request and making sure it passes your test. Like one best thing is make sure that it only comes from a list of known good items. Otherwise, you make sure it doesn't have a dot in it or a slash in it and things like that. Make sure it has the right extension, that sort of thing. This is called sanitization. You don't trust the parameter, you check to make sure that it's an acceptable value. It's a very good question. Anyway, so Ruby on Rails it was developed in Japan. I think Ruby is a very beautiful language like C, and for a while this was all the rage. Everybody would use Ruby to write applications. It seems to have gone out of favor. I don't hear much about it anymore. But it's a more elegant, more modern language than PHP to do essentially the same thing, and was hot for a while, but I don't hear it much anymore. However, SQL is huge, and that's why I'm going to demonstrate the SQL injection project later. SQL is used everywhere. Everybody that stores any kind of data pretty much stores it with one version or another of SQL. There's Oracle, which is a big, expensive enterprise-class SQL used by large companies. There's Microsoft SQL, which is for more intermediate business. You run it on a Windows server. And then there's MySQL, which is used on Linux boxes, and it's free. And they all do the same thing. You can send queries to create databases, to add records, and query the records. So you got tables. Each table can contain rows and columns. And you have queries, which can read, add, update, or delete data. And a large number of websites have SQL injection. A hacker named Rainforest Puppy discovered SQL injection, I think, about 20 years ago. He's now working at Cloudflare, or not working at Blue Box. He might have moved by now, but he was a well-known security expert. And it turned out that about 11% of websites have SQL injection. The last I heard, 11% of them still do. Every time you patch one, another generation of coders come up and make the same mistake again, which is a huge problem. A fundamental problem in this whole business is that most coding programs do not teach people any security. So they just write another generation of the same broken junk over and over again. And that's why I'm now teaching secure coding classes as a consultant to a big company, but most colleges don't offer it. Most companies don't train their developers with it. It is a new thing to teach secure coding, and nobody knows how to do it yet. It is not normally done, which is a shame. It means we just have many people that come up and make the same mistakes over and over and over. Anyway, so XML is a way to encode data to make it machine readable. So if you want to send up a pet named Ginger and a group of pets like a dog and a cat, this is just how you do it. It looks like HTML, but it's the generalist language. You have data, you have name of the data, and then a slash tag at the end of it. And you can have this pets container which contains both the dog and the cat. That's all. This is just a way to organize data, to send it on stick it in a machine read it, and transmit it. All right. Then there's SOAP. SOAP is Simple Object Access Protocol, where you can send an HTTP request with XML information, and it will use it to get data from the server. So you send this kind of request, a post with HTTP 1.0 and the usual header, then a blank line. This is how post lines work. You have a content length which tells it how many bytes of data you're sending. They just put N and N here. They didn't bother to put the exact number. You'll need to have a real number here. Then you have a blank line, and after the blank line, you have that many bytes of data, which can be processed by the server. And in this case, they're using XML data. So this tells you the XML version, and then you have something called SOAP envelope here, and slash SOAP envelope, and so on. This is what SOAP looks like. It's XML-oriented data called Simple Object Access Protocol, and you send up a request, and then the server expects SOAP data, reads it, and figures out what response to give you. It's just a way to organize the data that you're sending and receiving from the server. And so here's a SOAP response. You just get a response back, XML again, SOAP envelope, and in here comes the data. This is the quotation. So this one here asked for a quotation named Microsoft, and the response was this quotation. Here's the quotation. So, it's a simple way you'd make a simple request to a server and get a response like you might in a phone app. It just wants, I need to know this person's number, get it from the database. It'll fetch it, just send you that little bit of data, not a whole web page. All right, so that's SOAP. Now, if this data here, like this thing here, Microsoft spelled wrong, the question is, where did this come from? And this might have come from the user, like a search box. You type it in, and then it's just put in here. And if they don't sanitize it first, I could have injected XML tags into that name. And then I would be able to modify the functionality of this request, or the functionality of how it's processed on the server, if they allow me to inject these less than and greater than signs in my name. So that's the fundamental problem of almost every attack we're going to do all semester, is user-supplied data is used in the request, and you don't figure out how to stop them from injecting code in with the data. Code injection is very common in the heart of almost all these vulnerabilities. So the SOAP, the server has a web services description language where it describes what services it offers, and there's tools like SOAP UI you can use to develop the proper SOAP requests and SOAP responses. So let's take a look at a Kahoot about this stuff. All right. C, that's where we are. All right. Oh, by the way, if you're looking for a job, you should be skipping this class and going to the job fair. But anyway, it's happening right now on Zoom. Yeah. All right, maybe this isn't enough. Let's see. I'll give it a few more seconds. All right. All right, so what system uses POJO? That's Java, plain old Java objects. All right. All right, what language is used on LAMP servers? All right, PHP. That's the P stands for PHP. All right. All right, what system looks like that? Should be a slash there. There's a typo in the question. That's XML with a typo in it, but still XML. All right. All right, what system uses WSDL? Yeah, that SOAP uses this web services description language to advertise what kind of SOAP requests you will accept. All right, so this is Alexander. That you works, okay. And, okay. And Orks is your real name, right? Okay. Yeah, but I mean, is that the one we're going to be able to figure?
I use Orks in CCSF system.
What's that?
I register Orks as my name.
Oh, so you're in the, okay, so Margarita will find it. Yeah, okay, that's fine then, good.
My official name is mine.
That's good. I just wanted to make sure it's close enough to your real name she can tell who you are. Okay, good. Thank you. Anyway, by the way, it occurred to me, I'm going to stop this recording and make another one because there's a separate issue to tell you about.